Okay, in this video I'm going to go over some of the items you need for the 5.1 quiz that's upcoming. So the first thing you're going to need to do is I'm going to say look at video for special triangles. So where is this video? Well, this video was on the day of your Chapter 3 test. It was the assignment that night, and it went all through special triangles. So just to recap slightly, although I think you're still going to want to look at this video, here is a right triangle. It is going to be a 30, 60, 90 triangle. And in a 30, 60, 90 triangle, you have certain patterns. And this is the pattern. This would be side A, this is side 2A, and this is A root 3. And if that doesn't seem familiar to you, then that tells me that you never looked at the video. And that was a mistake. Okay, the other type of triangle we have, and you can still rectify that mistake. So I would highly encourage you to do so. This is 45 and this is 45. The pattern there is A, root 2. So a couple of things. If you're going to be solving triangles, let's just say, we'll do an easy one first. What if I told you that this was, I'm going to say this is 60, so you have to know that other side's 30. What if I said this was 4, and I asked you to find the other two sides? You would have to say, okay, so A is 4, so therefore my hypotenuse, which is 2A, is going to be 8, and the side across from the 60 is going to be A root 3, and since A is 4, it's going to be 4 root 3. Okay, so that's how that works. So let's try a more complicated one. What if I told you instead, what if I gave you, I'm going to make this 30 this time and this 60 this time. What if I told you the side across from the 60 was, let's say it was 6. And I say, I want you to tell me all the missing sides. Well, what do you know? You have to know that 6 is going to be A root 3 because it is across from the 60-degree angle. And anything across from the 60-degree angle is going to be A root 3. So I need to get my A because that's going to let me get the opposite two sides. So if I divide this by radical 3 to get my A alone, I get, I'm going to do it this way, that A is 6 radical 3. Now in our class, we cannot leave the answer like that. You cannot have a radical in the denominator. That is considered improper in our pre-calculus class. You have to rationalize it. You rationalize it by multiplying it by a fancy 1. The 1 is derived from whatever's in the bottom down here, you put it over itself. So you are in effect multiplying by a 1. Then multiply straight across. In the numerator you get 6 root 3, and in the denominator, radical 3 times radical 3, or root 3 times root 3 is 3. Okay, this 3 can go into the 6 twice, and you're left with A is 2 root 3. Okay, so I want to find the two missing sides. I know the hypotenuse is 2A. 2A is 4 root 3. Do not multiply underneath the radical. And then A, as I said, is 2 root 3. Okay, so those are some examples for special triangles when you have a 30, 60, 90. And as I said, you can go back on Google Classroom and look at when you took the Chapter 3 test, and the assignment that night was to watch the video on special triangles, and that will explain it more if you need additional information, which you may. Okay, next thing, let's look at the second type of special triangle, and that is a 45-45. So let's just say I drew a triangle. Well, I gave you some information about this triangle, and I told you that the side of a 45-45-90 triangle is, I don't know, 15. Find the other two sides. So you would say, okay, looking at this model, The other leg is also 15 because they are both A. And then the hypotenuse is going to be 15 root 2 because that is A root 2. Okay, so that's easy when they give you a side. What if they give you the hypotenuse? How can I deal with that? So why don't I say, let's see, what if the hypotenuse of a 45-45 was 50? Okay, I'm just going to make it 50. So when I look at this, I know that 50 is the A root 2 side. I've got to memorize those. This is the A side. This is the other A side. So 50 equals A root 2. Isolate your A by dividing by root 2. Then you want to remember that you cannot ever leave a radical in the denominator. So I'm going to rationalize it just like I did. And that gives me 50 root 2 over 2, which is 25 root 2. So that means the other two sides are 25 root 2 and another 25 root 2. Okay, so there's a couple of examples, and now you have a good idea of what you need to go over to master your understanding of special right triangles, okay? All right, that's one topic. Okay, another topic is coterminal angles. So we'll change my color, and we'll talk about coterminal. So remember, we are dealing in radians as well as degrees. To get a coterminal, you add and subtract 360 if you're in degrees, or add and subtract 2 pi if you're in radians. All right, so let's work with some of the problems that we had in our degrees and radians conversion practice. Okay, so if I want, what if I want two coterminal angles to, I don't know, we'll say 500. So my angle is 500. I want a positive coterminal and a negative coterminal. So when I do that, and again, you can use your calculator for this. Grab my calculator so I can do it quickly. Okay, so 500. To have it be positive, it has to be greater than 0, right? So I could even subtract 360 and still be positive, right? So if I take away 360, I get 140 degrees. That's a coterminal angle. Let's subtract away 360 times 2, which is 720. So 500 minus 720, that gives me negative 220, and that's going to be a negative coterminal angle. Okay, so when dealing with degrees, you either subtract or add to get a positive angle, and that's what I did here. So I subtracted to get a positive angle because my angle originally was so big. Or you can, and then, to get a negative coterminal, you've got to subtract enough to make it be negative. So in my situation here, I had to do it twice. And 2 times 360 is 720. That gave me negative 220. Okay, and you can continue adding and subtracting 360 to get additional coterminal angles. What if you're in radians? Because that tends to be where we're going to have our problem. So what if I had something like, I don't know, let's say if I had, oops, let me not do that in marker. What if I had, so pi over 5, and I want a coterminal angle, and I want a positive coterminal angle. So I'm going to add 2 pi. Now, I'm not going to be able to add 2 pi, which is a whole number, to pi over 5, which is a fraction, unless I multiply 2 pi by 5 over 5. So I'm doing that. When I do that, pi over 5 plus 10 pi over 5, that gives me 11 pi over 5, and that is a positive coterminal angle. All right, let me get a negative coterminal angle. As I already know, that when I multiply by 5 over 5, I get 10 pi over 5. Let's subtract 10 pi over 5. And you want to recognize that this is equivalent to 2 pi, because 5 goes into 10 twice, and then you have 2 pi. Okay, subtracting 1, because you have a 1 here, 1 minus 10 is a negative 9 pi over 5. And that's how you get coterminal angles. Okay, easy peasy. Know how to handle the fractions. And know that it's plus and minus 360 because you're going around a whole circle. Okay, so let's just go over the theory of this. When you're here, if this is your initial side right here, and this, say, is your terminal side, coterminal angles have the same beginning and end. So let's just say that this was, I don't know, we'll say this is 70 degrees. That's where it begins and ends. If you go around again, another circle, that angle is 70 plus 360, which is 430 degrees. It has the same beginning, the same end. Let's go negative. So 70 minus 360, that's going to give me negative 290. Where is that? So if I am going to go negative, okay, same initial side. Now let's go negative 290 is here. So this red is negative 290 degrees. It has the same initial side and the same terminal side. So what I found visibly here is that a coterminal angle to 70 degrees, a positive coterminal angle would be 360, and a negative coterminal angle to 70 degrees would be negative 290. Okay, so that's the theory behind it. All right, other thing we're going to ask you, we might have you going inside a certain interval. So let's talk about that for a second. So what if I say to you, I want to have an interval, so we're going to narrow down an interval from negative 360 degrees to 0. And your initial angle is 40. So I need to get a coterminal within this range. So to do that, what I'm going to do is I'm going to subtract 360. So 40 minus 360 is going to be negative 320, and that falls in between that range. So negative 320 suffices as being a coterminal angle within that range. Okay, and you can do the same thing with radians. So let's say I want to have negative radians. We'll do that since that's usually the hardest. So if I want to have an angle between negative 2 pi and 0, and let's say I have, let's say I have pi over 2. So pi over 2, and remember that I have to make it negative, so I'm going to subtract 2 pi over 2, 2 pi, let's see where I get. Multiply this by 2 over 2, so I have the same denominator. So that's pi over 2 minus 4 pi over 2. And what does that give me? So 1 minus 4 gives me a negative 3 pi over 2. Now, what is that? Well, 3 halves, negative 3 halves, is a negative 1.5 pi. If you think of it as a decimal, then it is indeed between 0 and negative 2 pi. So negative 3 pi over 2 works as the coterminal angle in this range. Okay, so we've done coterminal, we've done radians, we have done degrees. So let's go on to another topic that will be assessed in this quiz. Can you convert your angles? So let's talk about that. If you want to convert, let me just spell this right. If you want to convert from degrees to radians. Okay, so let's say we have, I don't know, 200 degrees. Your conversion factor is going to be pi over 180. That is your conversion factor. Okay, so reduce this to simplest terms. I'm going to divide by 10, and then I'm going to divide by 2. This is 9, and this is 10. So this equals 10 pi over 9 radians. So if you desire radians, have the pi be on top. What if you're going to convert instead from radians to degrees? Okay, so what if I had, I know, why don't I say I have pi over 3 radians? Now, you won't always have the pi in the radian degrees, in the radian angle measurement, but you will have the absence of a degree sign. So we're going to do another example so you get that. Okay, if you're going to convert from radians to degrees, you're going to multiply by 180 over pi because you desire degrees. So that's why degrees are on top in your multiplier. Okay, in this situation, the pi's cancel. 3 goes into 180 60 times. So my answer is 60 degrees. Okay, what if instead I said that I had an angle of 2 radians? Notice there's no pi there. And I want you to convert 2 radians to degrees. Because you desire degrees, the 180 is on top, but this time the pi is not going to leave your problem, right? So you're going to end up with 2 times 180, which is, 360. And what do I know? These are going to be in degrees, and that's why I have the degree symbol. So your big takeaway is this. When you're in radians, you do not have a degree symbol. You don't have it there, and you don't have it there. When you're in radians, you might have a pi in your angle, but it's not required. When you're in degrees, you must have a degree symbol. No matter what, you have to write the degree symbol in, otherwise you're not in degrees. Okay, so that was converting. You need to know that as well. Okay, how about identifying which quadrant each angle is located in? So first off, we need to know our quadrants, and we need to know what's in each quadrant. So you've got to memorize the numbering system. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So in terms of degrees, this is 0, this is 360, this is 90. So that means in quadrant 1, I'm between 0 and 90. In quadrant 2, I'm between 90 and 180 in degrees. In quadrant 3, I'm between 180 degrees and 270 degrees. And in quadrant 4, I'm between 270 degrees and 360. What about radians? Let me change the color for the radians. We'll make radians red. In radians, I start out with 0 here, and I go to pi over 2. And you may like this to be 0.5 pi instead, so that you can more easily determine where you are. Okay, 180 is just pi. 3 pi over 2 is 270, but you might want that as 1.5 times pi. And then between between 3 pi over 2 and 2 pi, is where quadrant 4 lives. Okay, so let's figure some things out. What if you had, let's see, what if you have 8 pi over 4? And I want to know where, we'll make it over 5. We'll make it over 5. Over 5. Okay, I want to know where that is. Well, 8 over 5. 8 over 4 is going to be 2. So this is greater than 2. So that means you've gone around the circle and you're going a little bit further. So 8 pi over 5, let me make this look better, is going to be in quadrant 1. So another thing you can do is you can say, what is 8 divided by 5? And that's 1.6. So here, let me recap for a second. Yeah, let me not do that one. So we're gonna scratch that one. So I want to do things that are a little bit easier. So what if I say, okay, where is pi over 12? Where is that? Well, this is 1/12 pi. So 1/12 is definitely less than 0.5. So think about this as 1/12 pi. So that's going to be in quadrant 1. Okay, what about if I have 5 pi over 4? So what is 5 divided by 4? That's going to be 1.25 pi. Okay, so where is 1.25 pi? Well, that's greater than pi, but less than 1.5 pi, so that's going to be in quadrant 3. All right? And notice I'm not changing these to degrees, although you certainly could do that, but that's a little bit longer way around. How about if I had 7 pi over 4? Well, what is 7 divided by 4? That's like 1.75 pi. So that means it's greater than 1.5, but less than 2 pi. So that's going to be in quadrant 4. So use your fractions. Okay, the other thing you can do is you can get back on this circle. What if you had a number that was greater than 2 pi? Okay, so what if I say 7 pi? What quadrant is 7 pi located in? So what could I do? I could subtract 2 pi. That gets me 5 pi, but that's still too big. Subtract 2 pi again. That gets me 3 pi, still too big. Subtract 2 pi again, and that gives me pi, which is a quadrantal angle, so it's located right here in between quadrants 2 and 3. So we're not going to ask you about the quadrantal angles, but we are going to require you to use your coterminal angles to get back on this circle. Okay, so that's going to be a requirement. You may find the degrees a little bit easier. So let's try some degrees. So I'll change my color. Where is 800 degrees located? So why don't you subtract 360 twice? That's going to be 720. That's going to equal 80 degrees. And where is that located? Definitely between 0 and 90 degrees. So that's going to be in quadrant 1. Okay, so do more practice of this as needed, but you need to be able to put your angles into the correct quadrant. Okay, the next thing we're going to be doing is using the two formulas that we had. So the two formulas that we've used is arc length equals the radius times the angle, and the area of a sector equals 1/2 r squared times theta. Okay, so what does all this mean? If I have a circle and I have angles inside of that, those are called central angles. So let me just make this little thing right here. So what if I say that R equals 3, and this out here is your S, which is your arc length. What if that equals 7? Can you find theta? So you would say S equals R times theta. I have the S, I have the R, I just don't have the theta. So solving for theta, 7/3 radians equals theta. Okay? So things to know. You have to be in radians. So I'm going to say theta must be in radians. If you're not in radians, you have to first convert. All right? What if they give you instead, if they say to you, I'm going to give you a picture because some of you got very confused with the pictures, which was supposed to make things easier for you. What if I had this situation and I said the area, what if the area equaled, oh, I don't know, say it equals 7 pi. So I told you the area, and I told you that the radius equaled, I don't know, we'll say 3.5. We'll make it easy. And I say to you, I want you to find theta and also find your arc length. And the arc length is out here. So I don't know this. And I do know this is 3.5. And I do know this is 7 pi. Okay, so you've got these two formulas. So right now I have area and I have the radius. So I can't go directly and find the S because to find the S, right, S equals R times theta. And I only have R. So I can't use this equation if I don't have the arc length or the theta. So I'm going to first find the angle. And I can do that because look what area equals. Area equals 1/2 R squared times theta. So I have area, which I said is 7 pi, and that's going to equal 1/2. So this is 7 halves. So 7 halves squared. Well, when I make these numbers better. So hold on. Let's just make this 3 so I don't deal with halves. We'll make it 4. So make the radius 4. Okay, so the radius is now 4, just so we can deal with these numbers without getting lost in the details. Okay, so this is going to be 4 squared times your theta. Okay, so far I have 7 pi equals 1/2 16 times theta. 2 goes into 16 8 times. So 7 pi equals 8 times theta. So 7 pi over 8 equals theta. First thing solved. Now that I have my theta, and I already had my radius, I can now say, what's my sector length? Well, that's going to equal the radius that was given, which was 4, times this angle, which is 7 pi over 8. This 4 goes into 8 2 times, and my arc length is 7 pi over 2. So now if I was going to diagram this arc length is no longer a question mark. This equals 7 pi over 2. And my, what else did I figure out? My theta was 7 pi over 8. Remember, this is your theta. So right here, theta is 7 pi over 8. And remember, that's going to be in radians. Okay? So we have one more topic we want to cover, and it has to do with shadow problems. So shadow problems are dependent upon similar triangles. So this is also something that we covered. So let's talk about that. So why don't, if I gave you a diagram, say that I I want to know how tall my house is. Okay? And I know that the house, so this is going to be question mark how tall it is, has a shadow length of, oh, let's say 40 feet. Okay? And let's say my husband stands outside and he's 6 feet tall and he has a shadow length of 3 feet. Okay, I want to know how high is the house. So what I'm going to do is I'm going to say these two triangles are similar. Why are they? Well, this angle is a right angle because I'm assuming that my building stands straight and my husband's standing straight. Then the sun is making the angle, correct? So this angle right here is going to be similar to this angle because it's under the same exact sun. So that means by angle, these two triangles are similar. If that's the case, all their angles are going to be equal. So I also know that this angle is going to equal this angle. And the sides are in proportion. So that means that the height of a building, my house in this situation, is to my husband's height, just like the shadow of the building is to my husband's shadow. Okay, so 3x equals 6 times, oh, you do cross products, by the way. So I'm doing this. I'm going this way equals this way, because when you have fraction equal to fraction, the product of the extremes, and that's technically this and this, equals the product of the means. Okay, so 3x equals 6 times 40, and 6 times 40 is 240. Divide by 3, and the house is 80 feet tall. Okay, so you want to know how to do shadow problems. And sometimes you'll do like angle placement problems. And in this situation, it's going to probably be a special right triangle. So you could say that you are going to, I don't know, say there's a fire over here, and you come running and you have the ladder, and you're going to place the ladder against the building and say that I know that the angle between the ladder and the ground is 30 degrees. That's my tip-off. I'm going to use a special triangle. So let's say that I knew my ladder was 100 feet long. My ladder is 100 feet long. I want to know how far up the building will the ladder land. Okay, so if it's 100 feet tall, 100 feet, if the ladder is 100 feet long, then that means that this is the 2A side, this is the A side, this is the A root 3 side. So I can tell you that when I place the ladder, when I'm using this 30-degree angle, it's going to hit the building at a height of 50 feet because 2A is 100. What's the distance from the foot of the ladder to the building along the ground? That's going to be 50 root 3. So if they give you special triangle values, you can answer all kinds of questions. So just be aware of that. I can do the exact same thing with a 45, 45, 90 triangle. Okay, so this covers all your topics. In terms of these formulas right here, this one and this one are going to be given. Okay, we'll definitely give you those. We are not going to give you the conversion factor. You have to know this. So you have to know that 180 over pi is used as a conversion factor from radians to degrees. And pi over 180 is used as a conversion factor from degrees to radians. You have to know that. You have to know your special triangles. We are not going to give you the breakdown. We're going to probably tell you it's a right triangle and tell you one of the angles. You have to know the rest. You have to know the A root 2 for the 45-45. You have to know the A2A, A root 3 for the 30-60-90. You have to know how to get to coterminal angles, whether you're getting them with degrees or radians. So plus and minus 360 in degrees, plus and minus 2 pi in radians, and you have to be able to deal with the fractions. You have to know the quadrants and which angles are found in which quadrant. And you're going to be able to use your calculator for all of this. So those are your topics. The homework that we have done has supported your practice of this. Go back over it, view the video on special triangles as needed, and you should be fine for this quiz.